Hello students, today we are going to take up the topic sulfur under P block elements group 16. So, thought for the session is I never lose, either I win or I learn. So this we should have the attitude in our mind. So learning objectives, learning outcomes are, so you will be able to explain about allotropes of sulfur, structure of sulfur, action of heat on sulfur, extraction of sulfur from FRASCH process. So let us start a brief discussion about sulfur. As you can see, the color is yellow. Atomic number 16, atomic mass 32. As you see the crown, the structure is like crown, and sulfur can be oxidized to sulfur dioxide. And you know that sulfur dioxide is one of the component of acid rain. And there are different forms of sulfur as you see from the page, rhombic, monoclinic, and the temperature variation may transit the two allotropes. And sulfur is basically insoluble in water but soluble in carbon disulfide, and it was known very long before because it was used in medicine purpose and for fumigation also. And the first elemental state of nature was explained by Lavoisier in 1777. Okay, so now I am going to talk about the classification. So classification of sulfur includes the crystalline and amorphous forms. Crystalline form includes the two forms rhombic and monoclinic, and rhombic basically octahedral is there. If you see from here, this structure is octahedral. Okay, this is also octahedral, only the shape is a little bit different. And this is S8 shape, this is 6. Now, the point is monoclinic, that is beta sulfur. These two are crystalline form, and amorphous form is plastic, colloidal, or milk of sulfur. These are the three forms. As far as our syllabus is concerned, these two forms, crystalline form is that defined in the syllabus to cover up. We will focus more of our studies on rhombic and monoclinic. Okay, so as far as properties are concerned, we are going to discuss further about rhombic and monoclinic. So what are these properties? These are allotropes. Allotropes, you know, those who are having different physical form but same chemically. Or when you heat, let us say rhombic sulfur or monoclinic sulfur, you will get sulfur dioxide. On oxidation is there. But the two forms, their melting point may be different, the properties, the color may be different. Okay, so these are differences there. Their structure is different, their shape is different. So these, the physical properties are different but chemical properties are same. That are known as allotropes. Rhombic and monoclinic sulfur are crystalline allotropes of sulfur. And plastic is coming under amorphous form. Plastic, we will not concentrate more on that. It is also known as gamma sulfur. Okay, and it can be obtained from monoclinic or rhombic sulfur. It is a soft rubber like amorphous mass, and its specific gravity is less than the two forms of sulfur like alpha or beta. Alpha means rhombic, beta means monoclinic, and gamma means plastic sulfur. Okay, and apart from that, you will find the sulfur as in the book milk of sulfur. But basically it is not defined in the syllabus, so therefore I don't want to focus more on that. So milk of sulfur is obtained when milk of lime, like that is calcium hydroxide, CaOH twice. When treated with sulfur, the products are formed as calcium pentasulfide as well as calcium thiosulfate. So this on further treatment with hydrochloric acid, we are getting the milk of sulfur, that is occurring as a white amorphous precipitates. So this is known as milk of sulfur. Okay. And moreover, colloidal sulfur is also there when we are making the solution, colloidal solution like hydrogen sulfide, then when we pass through HNO3. So then colloidal solution is formed. So that type of that comes under colloidal sulfur. So overall, if we see, there are 5 forms of sulfur. First we have discussed already, that is rhombic, then monoclinic. These two are in our syllabus. Rest 3 like plastic sulfur, milk of sulfur, and colloidal sulfur are not specified in the syllabus, but brief discussion I have given to you. Plastic sulfur is having open chain of acid molecules. Okay. So next thing is regarding, we are going to detail the form of allotropic form of sulfur, that is rhombic and monoclinic. You can see the structures here. These are 8 atom structures, so rhombic structure and monoclinic. So this is the most stable form. Which is the most stable? Rhombic or alpha sulfur. It is obtained by slowly evaporating a solution of rolled sulfur in carbon disulfide. As I told you that the sulfur is dissolved in carbon disulfide. When octahedral crystal of rhombic sulfur are formed, this is lemon yellow in color. Okay. So monoclinic, that is beta sulfur. If crystals of rhombic sulfur, it means monoclinic sulfur we can obtain from alpha sulfur or rhombic sulfur, and these crystals are obtained when you slowly heat it to 369 Kelvin. Why slowly? Because increase in temperature brings a drastic change in the sulfur forms. Okay, we'll discuss that in detail. They slowly change into needle-like variety called monoclinic. It means the only difference is the shape. There it is octahedral. This is monoclinic, that is needle-like shape. Okay, and this form is stable above 369 Kelvin, and if the temperature you are going to decrease, this monoclinic may go back to rhombic sulfur, and it is having dull yellow color, and as against the lemon yellow color in case of allotropic form of sulfur. So now, as we were talking of the temperature, if temperature is more, let us say above 369 temperature, then it will change into monoclinic. If temperature is decreased, then again it will go back to rhombic sulfur. So this is the rhombic sulfur, also known as crown shaped structure, like crown, king's crown is there. So that's what we say, crown structure. Now the basic difference in the physical properties are, the rhombic sulfur is a bright yellow, just now we have discussed lemon yellow, bright yellow, and here it is pale yellow, monoclinic crystalline solid, and its melting point of 113 degrees Celsius, melting point of 119 degrees, means little bit melting point is higher in case of monoclinic sulfur, and density is maximum in case of rhombic sulfur, and monoclinic is 1.96. If you are talking of plastic and all that, that is still lesser than that. That might be 1.95 gram per centimeter cube. And rhombic sulfur is stable below 96 degrees Celsius, but monoclinic is stable above 96 degrees. This is the only main difference there. And has octahedral structure and needle-like structure. So what is the transition temperature? Temperature 90 degrees Celsius. If you increase the temperature, then rhombic sulfur will change to monoclinic. If you decrease the temperature, then monoclinic will change to rhombic. This is the transition taking place under the two allotropes form of sulfur, which are crystalline in nature. Now this is one of the important topic which is specified in the syllabus also, effect of heat. So as you see that we have discussed already that rhombic sulfur is having melting point of 385.8 Kelvin. Okay, so as you increase the temperature, that may go to monoclinic. So now the point is, the sulfur, the rhombic sulfur, when you heat to 85.8 Kelvin, it will form liquid, pale yellow mobile liquid. But what is the properties difference is there? When you heat little bit more, this pale yellow liquid will become thicker. Normally, what is happening? When you heat any solid substance, it will change to liquid, and liquid will flow very fast as you are increasing the temperature. But here its case is opposite. What is happening? It's going to be more viscous. What is the reason for that? And again, if the color also changed from pale yellow was the previous color, that will change to dark brown. Now the point is, if you further increase to 453 Kelvin, it will become so viscous that does not flow and it becomes so immobile. Let us say if you are taking that in the test tube and heating at 453 Kelvin and invert the test tube, that will not come out. So that is the point. So now this is the property which differentiates sulfur from just other substances which flow on heating. At 718 Kelvin, it flows freely and starts boiling, giving off reddish brown vapors. So means to say that if you increase further temperature to 718 Kelvin, so earlier it was becoming viscous and viscous, now it starts flowing again, it starts boiling again and giving off the vapors of S8. If you continue to heat that solution, it will form vapors of S2, S4 and finally sulfur. That also will get broken into two atoms, that is sulfur at 2273 Kelvin. Now the point is, what this is happening? The melting happened, the viscosity increasing happening, and at point came the viscosity is maximum, and then again viscosity is decreasing, and then free flow is there, and then decomposing into fumes, into S2, S4 and What is this? So we can discuss that why it is happening that. The reason for that is, you know that rhobic sulfur is having puckered ring structure where each sulfur atom is linked with 8 other atoms, or we are having total 8 atoms, S8, and it's a crown ring structure, that is also known as puckered ring structure. This structure remains intact at just above temperature of 385.8, means to say that at just the melting point, if you are not going to increase more temperature, the structure remains intact. There is no loss to the structure of crown ring or puckered ring structure. But when the sulfur is heated beyond that, it starts melting, and these rings, sulfur 8 rings, just slip over one another. One sulfur ring will slip over the next, then third, then fourth, like this. So this pale yellow liquid is mobile. That is the reason that till that time on heating, mobility is still there. But if further heating is continued, what is going to happen? Which was a ring was there, sulfur 8 atom rings was there, that just get broken. So this, once the sulfur puckered ring structure gets broken, it becomes open chain, and open chain will cross link with each other or entangle with each other, resulting in an increase of viscosity, and it leads to the poor movement or no movement of the molecules. Now the point is, that's the reason that as you are increasing the temperature beyond 385.8 Kelvin, it starts becoming more viscous and less mobile. So next is further heating. What is going to happen? If you heat at 718 Kelvin, what is going to happen is the viscosity again started decreasing. Earlier viscosity was increasing in between. Now viscosity starts decreasing, and this entangled molecule will change into S2, S4. And if you further heat this substance at 2273 Kelvin, this S2 also will decompose into sulfur atoms. Now we are going to discuss about the last topic here, is extraction of sulfur. Strictly speaking, this is the important topic from this particular part. Otherwise, they are not asking any question about the rhombic, monoclinic sulfur and all that. Okay, so all the theoretical basic. Now, FRASH process, you try to understand what is there. FRASH process is having one 30 centimeter dia pipeline we are putting into the earth, deep into the earth, to get the sulfur in the pure form, molten sulfur. And you know that the technology, this extraction of sulfur, that is known as FRASH process, was developed by American chemist Herman FRASH. On his name, this process named as FRASH process. And you must be aware of that the length of the bed means where the sulfur is obtained, that might be reaching up to 125 feet down into the earth. So it's very difficult to extract as such with the normal procedure. To extract sulfur and purify it, it's very difficult. So this FRASH process, in this what we are going to do is 30 centimeter dia pipeline we are taking, we are inserting to the sulfur bed. So once that is okay, then we will insert concentric pipes of different diameter, like 15 centimeter, 7.5 centimeter and 2.5 centimeter. 3 concentric tubes are put into the 30 centimeter dia pipeline. Now 3 tubes are there inside that concentric tubes. You see, what we are going to do is, from the very small, very small, like that is 2.5 centimeter, we are inserting high pressurized air, compressed air we are pushing in the center channel, centermost, and on the outermost, that is 15 centimeter dia pipeline, we are pressurizing the vessel by passing superheated steam which is at temperature of 445 or 455 Kelvin. Now the point is why we are sending at this temperature. And you know that the melting point of sulfur is 385.8. So little bit higher the temperature we are using so that all the sulfur beds can change into molten state. And you cannot increase beyond that, then again problem might be there, viscosity and all that. Now, so once you have supply with the superheated steam and in the center compressed air is there, what is going to happen is this superheated steam will melt the sulfur beds surrounding the tube, which is 30 centimeter in diameter. Now the molten sulfur is ready to move up. How it will move up? When you pass the compressed air from the central pipe, that is 2.5 centimeter. Now only one pipe is left. Which pipe? In between the sender, which is compressed air, and the outermost layer where we are passing steam. So means to say that we will get the molten sulfur in pure form, that is 99.9% pure. We can obtain the sulfur from this flash process from the innermost from the sender, one sender pipeline. So innermost is used for compressed air and the outermost is used for the steam to melt the sulfur beds. Okay, hopefully you might have understood that. So you just read from the book. I think it is easy. The basic explanation I have given to you. So now summary for that is sulfur exhibit allotropy, yellow sulfur or alpha sulfur or rhobic sulfur is the name. Monoclinic sulfur is beta sulfur. At 369 Kelvin, both forms are stable. It is called transition temperature. Both of them have acid molecules. The ring has a puckered ring and has a crown shape. Another allotrope of sulfur is cyclo-SX. Okay, and it adopts a chair form. You can see from the chair form. Sulfur is formed at higher temperature. As we discussed that higher the temperature is there, sulfur will decompose, acid will decompose into sulfur 2 atoms or sulfur atoms. And this is paramagnetic in nature. How? Because you compare with oxygen O2. If you see the molecular orbital theory, the electron were there, unpaired. That was there in anti-bonding. Similarly, here also the same procedure will be applicable. Okay. So due to unpaired electron, it will show paramagnetic character. So let us test your understanding where sulfur is predominantly used. So answer is manufacturing of sulfur dioxide, which is used for fumigation and bleaching and sulfuric acid making by contact process. Second is manufacturing of matchsticks, okay, gunpowder dyes. Fungicide used in vulcanization of rubber, preparation of drugs and medicine. Allotropes of sulfur, which is the most stable. I told you already, rhobic sulfur is the most stable form which is existing as acid, and monoclinic plastic sulfur are the other two apart from the monoclinic. Okay, monoclinic and plastic sulfur, and one more was there. What was that? It was colloidal sulfur and milk of sulfur. So congratulations. The thought for the session again I would like to repeat: I never lose, either I win or I learn. Thank you.